morning, guys.
Hello.
Hello, Asmri.
Yes.
Yes, good morning.
Good morning.
What about the other students? مشعل and صالح.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته. هلا مشعل.
يا استاذ لازم ترسل الرابط يا استاذ، انت ارسلت له هذا قديم ما حد شافه.
هذا قديم يعني مش فاهم. عليكم السلام. هلا صالح.
ارسله مرة ثانية عشان يدخلون الناس.
ارسل مرة ثانية لأن أنا لسه أرسلت اليوم.
ايوه
ارسل
لكن
الحين يعني مرة ثانية.
أرسل الحين مرة ثانية يعني؟
يب لأن
خلاص.
الطلاب ما
It's okay. I will send it now. 9B9. It's okay. I sent it now. It's okay.
يس.
Now we have Mashal, Saleh, and Muhammad Asmari only. Not. Oh, what about all students?
الحين يجون يا استاذ.
مروان.
هم 17.
Yes, Marwan connected now.
هلا.
هلا مروان.
هلا والله استاذ.
محمد سعد. هلا.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته. Okay, guys, now we have what? Now we have Hussam, Muhammad Saad, Mishal, Muhammad Asmari, Saleh, and Marwan Ajam. It's okay?
Yes.
Where is Muhammad Saad?
Muhammad Saad, I think he doesn't have microphone.
No, Muhammad Saad have. Muhammad Saad have now. Muhammad Saad. Asmari.
Yes.
مشعل. مشعل.
Yes.
Yes, okay. Please. All students can answer me. Now, please. Okay. All students, please can answer me. It's okay. Asmari is present. He's present. Muhammad Saad. Not present. Saleh.
Yes.
Yes. Hussam.
مستر محمد تسجيل بس
Yes, Mr. Yes.
Yes, Hussam present. Ibrahim.
Yes, present.
Ibrahim, yes, it's okay. What is Muhammad Saad? Muhammad Saad is
He don't have mic, Mr.
Why not have mic? Why? But in front of me he have one. He have one. It's okay. Let's begin or wait for a while. Begin or wait for a while.
اللي تشوفه يا استاذ.
Up to you, Mr.
I think that participants now are 11. Hashim. Hashim is present. Ali.
Yes,
Thamer.
yes, Mr.
Thamer. Yes. I will take a copy from these participants and I will send all these participants to WhatsApp group. Okay? And there are marks for students that participate with me. It's okay? Yes, okay. Thanks, God. Yes?
Mr. I'm Thamer. I just want to ask you a sub question.
Yes, Samer, go.
if you remember last Sunday before they stopped the school, I put me and Mshari and Khad Faisal the things to do for the project.
Yeah, I think, yeah, I know. It's okay,
your
no.
tab.
Yeah, it's okay, I know. No problem, sir, no
يا
problem.
مستر
Yes, هلا هاشم.
في اختبارات
إن شاء الله يا هاشم، إن شاء الله.
ان شاء الله مستانس يا أستاذ.
إن شاء الله. Guys, now inshallah, I will going to make all students a mute. Mute. It's okay, but if any student, if anyone has a question, can raise his hand only, and I will see him. I will discuss with him in any question
Okay.
that he will need. It's okay.
Okay.
Okay. Thanks. And now, inshallah, we are going to begin. Okay, now we are going to begin, inshallah. Okay. Hello, everybody. Hello, grade 8. Now, inshallah, we are going to take lesson which is called Defining the Atom. It's the second lesson, Defining the Atom. Okay, and the lesson or the questions that you are going to study, that an atom is made of a nucleus, as we said before, containing protons and neutrons, electrons move around the nucleus. Okay, so an atom is made of a nucleus. This nucleus containing protons and neutrons. This nucleus containing what? Protons and neutrons. And there are electrons that move and revolve around the nucleus in 7 energy levels. It's okay? Listen, please. Listen.
Section 2, Defining the Atom. An atom is made of a nucleus containing protons and neutrons. Electrons move around the nucleus.
It's okay. After that, the second slide, that essential question that we are going to study. Okay, first, listen please.
Essential questions. What is an atom? How can the subatomic particles be distinguished in terms of relative charge and mass? Where are the locations of the subatomic particles within the structure of the atom?
So, this is the essential question that we are going to study, inshallah. Okay, what are the questions that you are going to study? Number 1, what is the atom? What's meant by atom? Number 2, how can the subatomic particles be distinguished in terms of relative change and mass, relative charge and mass? Where are the locations of the subatomic particles within the structure of atom? It's okay? It's okay. Let's begin. The vocab that we studied before, which is model. But the vocab that we are going to, okay, please, vocab that we are going to study, which is number 1, atom. Listen, please.
Atom. Cathode ray. Electron. Nucleus. Proton. Neutron.
It's okay, understand? Now, any problem? Has any question? Yes, Asmari. What do you need, Asmari?
Mr. What's mean by subatom?
Subatomic particles, which means protons, neutrons, and electrons. They are the contents of the nucleus and atom. We said before that atom has nucleus. Inside its nucleus, there would be protons and neutrons. And there are electrons that revolve around the nucleus in 7 energy level. All these particles called the subatomic particles. Understand?
Yes, thank you.
It's okay, thanks. Let's return, understand under this. After that, okay, the atom, okay, smallest, what's meant by atom? Atom is the smallest particle of an element that retains the properties of the element is called an atom. So it's the meaning of atom. So who can answer me? What's meant by atom? What's meant by atom? Okay. Okay, Thamer. Yes, please, Thamer, read.
is smallest particle of an element that returns that the properties of the element is called an atom.
Good. Thanks, Tamer, for your participation. Another one. And please, Tamer, make your hand lower. Okay. Mash'al. Okay. Go, Mash'al.
The smallest particle of an element that retains the properties of the element is called an atom.
Good. Thanks, Mash'al, for your participation. Third one. Who is the third one that can participate? What's meant by atom? Marwan. Okay, yes. Go, Marwan.
The smallest particle of an element that retains the properties of the element is called an atom.
Okay, thanks, Marwan. Saleh. Okay.
The smallest particle of an element that retains the properties of the element is called an atom.
Okay, thanks, Saleh, for your participation. Khaled Faisal.
The smallest particle of an element that retains the properties of the element is called an atom.
Good. Thanks, Khaled Faisal. Okay, thanks for your participation. Now, the second definition, which is what? An instrument called the scanning tunneling. Scanning tunneling. Microscope, STM, scanning, tunneling, microscope. Allows individual atom to be seen. Allowing what? Individual atom to be seen. So, we said the meaning of atom, that the smallest particle of an element that retains the properties of the element is called an atom. And the instrument that called the scanning, tunneling, microscope, STM, allows individual atom to be seen. Okay? After that, this is the device that, what's the importance of it? The electron. What's meant by electron? Okay, listen please. Number one, listen.
The electron. When an electric charge is applied, a ray of radiation travels from the cathode to the anode, called a cathode ray.
So, cathode ray, what's meant by cathode ray? When an electric charge is applied at this is a tube, free tube, empty tube. And this is cathode, which has negative charge. And this is anode, which has positive charge. And this opening connected to a vacuum pump. Vacuum pump to move or to remove air. To remove air from this tube to be empty. To be empty. So this opening connected to vacuum pump. Vacuum pump to what? What is the function of this vacuum pump? To remove all air which is found inside the tube. And this is the battery voltage source. This is negative pole, which is connected to cathode, and this is positive pole, which is connected to anode. So, when an electric charge is applied, a ray of radiation travels from cathode, okay, to anode, cathode to anode. So it's called cathode ray. Cathode ray, okay? Cathode rays are a stream of particles carrying a negative charge. Carrying what? Negative charge. The particles carrying a negative charge are known as electrons. So these are called electrons that move from cathode, which has negative charge, to anode, which has positive charge. So it's called what? It's called electrons. Okay, listen.
Cathode rays are a stream of particles carrying a negative charge. The particles carrying a negative charge are known as electrons.
Okay.
This figure below shows a typical cathode rate.
Yeah, it's okay. So first, please, to return to it again. Okay, so who can answer me? What's meant by electrons? What's meant by electrons? Khaled Faisal? Yes, Khaled?
Electrons. When an electron charge is applied, a ray of radiation travels from the cathode to the anode, called a cathode ray.
So it's called the cathode ray, but I need electrons, the meaning of electrons.
Oh.
The electrons are what?
Oh, yeah.
Stream.
Cathode rays are a stream of particles carrying a negative charge. The particle carrying a negative charge are known as electrons.
Good. So they are electrons. Thanks, Khalid. Okay, Ibrahim. Yes, Ibrahim.
Yes, yes, Mister.
Yes, Ibrahim. Okay, go. Go, Ibrahim. What's meant by electrons?
When an electric charge is
Ibrahim, no. It's the meaning of a cathode ray. Okay, it's called what? Called cathode ray, but I means electrons. What's meant by electrons? So you will begin from a stream of particles. Do you understand me?
carrying a negative charge. Yes, yes.
Okay,
A
so what's
stream
meant by
of
electrons?
particle carrying
Yes.
The
Yes, complete.
particle carrying a negative charge are known as electrons.
Electrons. So thanks, Ibrahim, for your participation. Khalid Faisal, do you need anything? I think that you still raise his hand. Your hand, sorry. Please make it lower. Khalid Faisal. Okay, thanks, Khalid, for your participation. Okay, so it's called what? It's called electrons. Okay, understand? After that, so the electron, G.G. Thomson measured the effect of both magnetic and electric field on the cathode, but what? On cathode by what? Hussam, mute for all, Hussam. For all. It's okay. So, listen, please.
The electron. J.J. Thomson measured the effects of both magnetic and electric fields on the cathode ray to determine the charge-to-mass ratio of a charged particle, then compared it to known values.
It's okay. At the Thomson. After that,
the mass of the charged particle was much less than the hydrogen atom, then the lightest known atom. Thomson received the Nobel Prize in 1906 for identifying the first subatomic particle, the electron.
Okay, so this is Thomson measured the effects of both magnetic and electric field. Magnetic and electric field, okay, measured by Thomson on the cathode ray to determine the charge to mass ratio. Charge and mass ratio of a charged particles, then compared it to known value. Okay, so Thomson measured the effects of both magnetic and electric field on the cathode ray to determine the charge to the mass ratio of a charged particles, then compared it to know its value. The mass of a charged particles was much less than hydrogen atom. So he noticed what? He noticed that the mass of these charged particles was much less than hydrogen atom. Then the lightest known atom. Thomson received the Nobel Prize in 1906 for identifying the first subatomic particles, which is called electron. It's okay? Understand? Any problem till now? Anyone has question? Any problem till now? It's okay. Thanks. After that, okay, after this slide, this is what? The device. Okay. What's the device? Okay, listen.
The electron. In the early 1910s, Robert Millikan used the oil drop apparatus shown below to determine the charge of an electron.
Okay, in the early 1910s, Robert Millikan used the oil drop apparatus. Used what? Used the oil drop apparatus shown below to determine the charge of an electron. Charge of an electron by this is positive pole, cathode, this is negative pole, anode, and this is a battery between them. This is the source of ionizing radiation. Okay, this is called atomizer. And this positively charged, we said telescope, okay, that produce this telescope, and negatively charged. Okay, after that, to determine the mass of electron. Okay, how he measured it.
The electron charges change in discrete amounts, 1.602 times 10 to 19 coulombs. The charge of one electron, now equated to a single unit, 1. With the electron's charge to mass ratio known, Millikan calculated the mass of a single electron.
This mass of single electron. Mass of an electron equal 9.1 times 10 power negative 28 gram. So equals what? Equals 1 divided 1840. It's the mass of hydrogen atom. So the mass of electrons is very, very, very small. That can be neglected. Can be neglected as we don't mind. We don't mind by it because it's very, very small. So the mass of the atom, mass of electrons is very, very small. That can be neglected. It's okay. Understand till now? Any problem? Any problem for anyone? It's okay. I think that after that, about the electrons, okay, matter is neutral. Matter is neutral. You know that matter is neutral from everyday experiences. You do not receive an electric shock except under certain conditions as temperature and pressure. When you touch an object, so any matter is neutral. An atom is a type of matter that's neutral, but in its ordinary state. Why is neutral? Who can answer me? Why atom is a neutral at its ordinary state? Who can answer me? Why atom? Why atom? Why atom is a neutral at its ordinary state? Why? Who can answer me? Who can answer me? Where is Bassami, Fahd, Smri, Hashim, Usam? Okay, Asmari, go.
I think, Mr. That because that the electron has negative charge, so that I think doesn't make shock or something like this.
It's okay, but it's not effective real. Why?
Yes.
Why? Because atom is a neutral. Why? Because the number of positive protons is equal to number of negative electrons. So when the number of positive protons become equal to a number of negative electrons, so it will be stable and it will be neutral. It will be what? It will be neutral. Why neutral? Because number of positive protons equal to what? Equal to number of negative electrons. Because number of what? Number of positive protons equal to what? Equal to number of negative electrons. Okay, so it equal what? So it's what? So it's a neutral. So it's what? A neutral. Understand me? Okay, any problem till now? It's okay. So after that, if electrons are negative, then how is matter? Which is made up of electrons neutral? Which is made up of electrons neutral? G.G. Thomson proposed a model of an atom to answer this question.
The electron. The matter is neutral. You know that matter is neutral from everyday experiences. You do not receive an electric shock, except under certain conditions, when you touch an object. If electrons are negative, then how is the matter, which is made up of electrons, neutral? J.J. Thomson proposed a model of the atom to answer this question.
Okay. As this. Okay. This means what? This means what? Okay. This matter containing evenly distributed positive charge, and it's electrons. So these electrons, okay, this is called electrons, and this matter containing evenly distributed positively charged. So it's a neutral. Why? Because number of positive protons is equal to number of negative electrons. It's okay. After seeing this, we are going to go to our McGraw-Hill, okay, and share what this is activity, okay. So is activity about the structure.
If you could see an individual atom, it would appear to be a solid sphere. But if you could take a closer look, you would see that an atom is made up of a few particles and a lot of empty space. The outer part of an atom consists of negatively charged particles called electrons.
This is called electron cloud. This is electron cloud. Cloud means what? Cloud means electron can be found in any place of this area, from this area to this. All this. Electrons can be found in any place. So it's called what? It's called cloud, electron cloud.
Electrons move in energy levels around a central group of particles.
This is inside the atom. This is the nucleus. This is the nucleus. Nucleus contains what? Nucleus contains what?
Particles called a nucleus. The nucleus is made up of particles called neutrons that have no charge and protons that are positively charged.
So the nucleus contains positive protons and neutral neutrons. Positive protons and neutral neutrons. Okay, so is the atom.
The number of protons in an atom tells you what element it is.
So particles of 3 atomic mass. Atomic mass means what? Atomic mass means number of protons and neutrons. Atomic mass means number of protons and neutrons.
Almost all the mass of an atom is in its nucleus. The total number of particles found there is the mass number. If a neutron is added to an atom of the same element but with a different mass forms. Atoms with the same number of protons but different numbers of neutrons are called isotopes. However, if the number of protons is changed, an atom of a different element is formed.
So it's what? It's meaning number of protons and neutrons. Okay, this animation. Okay, that show the structure of what? Show the structure of atom. Okay, in this activity, okay.
Hi, I'm Miss McKee. Today we're going to discuss the gold foil experiment. Due to experiments using cathode rays, J.J. Thomson, a British physicist, identified electrons for the first time in 1897. His discovery of electrons meant that atoms are composed of smaller particles than previously thought. Additional experiments determined electrons were very tiny, negative.
This is Thomson. This is Thomson atomic model. Thomson atomic model said that this is a ball of positive charge. This is a ball of positive charge that has negatively charged electrons. This is negatively charged electrons. Okay, so it's what? It's a Thomson atomic model.
Negatively charged particles. Thomson's discovery raised new questions. Scientists knew that matter is neutral. That is, matter usually doesn't have an overall electric charge. So what was inside the atom that balanced the negative charge of the electrons? Also, scientists wondered where the rest of the mass of an atom came from if the electron was so small. Thomson proposed that the atom consisted of electrons embedded in a positively charged sphere. This is Thomson's atomic model. In this model, the electrons are represented by red dots. The atom itself has an overall neutral charge. Thomson referred to this model as the plum pudding model, or cookie dough model as it's sometimes called today. In the early 1900s, Ernest Rutherford, a physicist and chemist from New Zealand, conducted experiments on the interactions of radiation and matter. Rutherford was aware of Thomson's plum pudding model and had expectations about how the alpha particles would behave in a neutral atom.
Okay, we are going to complete this video in next inshallah. Okay, but now we return again to our PowerPoint. That's the electrons. An event is with positive charge. Its alpha particles path. That's the nucleus. Okay, so from this nucleus, we are going to complete inshallah in next session. It's okay. We are going to complete inshallah in next session from this. Okay, from the beginning of nucleus and from slide number 11, we are going to complete in the next session inshallah. Thanks for participation. That this is the number of participation that participate with me now, and the number of these participants are 15. So I will send these participants to WhatsApp group. Okay. Any problem till now? Any problem for any student?
No.
No.
Understand lesson?
Yes.
Yes.
Thanks for your participation and see you soon inshallah. It's okay? Okay, thanks, my guys. Thanks. Good luck and goodbye inshallah. Okay, goodbye.
Goodbye.